The Druva Data Resiliency Cloud modernizes data protection across all your workloads by not only providing air-gapped backups, cloud-based disaster recovery, and long-term retention, but also providing a cloud-based scalable and secure backup ecosystem. It all starts at the Security Command Center. This single pane of glass contains many tools to manage, monitor, and secure your backup environment, and shows any security posture risks that your organization may be experiencing. With just a few clicks, you can quickly remedy any potential issues in your backups. Customers can configure MFA for additional console security, and full role-based access control ensures that least privilege policies are in place, making sure that users can only see what they need to within the backup environment. Geofencing can help lock down who has access to the console from various regions of concern, and a full audit log is available to make sure you always know what is happening in the environment. You can even integrate your audits with various logging tools such as Splunk. And you can't recover from ransomware if your backups aren't configured and working properly. So here we can see if any of our workloads are having issues backing up or communicating with the Druva Cloud. It's also sometimes too easy to forget about API keys and admin passwords that might be floating around. So we also let you know when an account hasn't been accessed in a while, or if there are stale API credentials not being used that could possibly be hijacked. At Druva, we think about the various timelines of an attack, and we realize it's usually not an instant thing. During the incursion phase, whether it's the ransomware software package itself, or it's the threat actor, the first thing that they'll do besides poking around and finding more information is they'll try to compromise the backup system. They have learned that a company without a backup usually has to pay the ransom, so they've changed tactics to sabotaging any recovery efforts first before initiating any attacks. Besides configuring security for best practices, we have an entire security events pane, which will show you access events for APIs and administrative logins. Here you can see where admins are logging in from, who's logging in, and what IP address they're using. Here's where geofencing can help at least eliminate some rogue logins, but IP spoofing can occur, so it's just one piece of the solution. Since the Druva solution is API driven, you can easily add many of the UI calls into APIs. But this could also allow for a rogue call to cause havoc in the same system if they aren't locked down. You can see more by drilling into any of these API calls, and you can get more information about who's doing it and where it's coming from. Druva backups are stored in the cloud with encryption in flight and at rest, but if a threat actor is able to log in and cause havoc, Druva has a feature called rollback actions. Rollback actions provide a secure, immutable read-only area with a retention window that stores anything that was deleted. This rollback area cannot be accessed by anyone, even administrators, so it gives you another safety net in the case of accidental or malicious deletions. So whether it's somebody deleting users, deleting profiles, deleting workloads, or deleting backups, those objects are stored for X number of days. For example, in here, you see it's 7 days. So now whether it was malicious or accidental, administrators can come into rollback requests, find what they're looking for, and roll it back into their primary backup environment, and then continue the recovery process. In addition to the rollback actions and the encryption in flight and in rest, Druva also stores all of the backups chunked up in S3 buckets, which are isolated from any sort of ransomware attack as well as any sort of execution. In addition, for that additional layer of immutable backups, customers can enable something called data lock. Once something has been configured for data lock, it cannot be deleted or moved or changed until the retention policy is over. Any of your backup sets can be configured to change to a data lock policy, but at that point, all of the backups from the past and anything moving forward will now have that data lock retention setting. So between the secure cloud operating model of Druva, customer security settings, event logging, rollback actions, data lock, your backups are protected in the cloud. Now, beyond the threat actor messing around in your backup ecosystem, ransomware itself is going to start impacting the files within the organization. We've seen that dwell time for ransomware can be in the multiple week time frame, slowly encrypting, slowly modifying, and sometimes it can't be caught until it finally locks everything down. Across multiple workloads, we have unusual data activity alerts, which monitors the backups for things like deleted files, encrypted files, and anything anomalous to your normal backup routine. You may not encrypt 20,000 files on a Friday afternoon usually, so when we see something like that, we want to make sure you are aware of it. It could be a precursor to an event, and can also be used during forensics when looking over timelines of when things have happened. Leveraging what we see holistically across all of our anonymized backup sets from all of our customers lets us notice when something just isn't quite right, and we can alert you. even inside your virtual machines. And once you have a good handle on your own backup sets, you can even modify the UDA settings to truly customize what kinds of anomalous behavior you are looking for. Once we get to the investigation phase of things, we might have information come from the security team. Things might have come from the fact that a virtual machine is actually locked up, so now we know that there's an active attack. One of the things we can do is quarantine the backups from that resource. This prevents any recovery from that resource until you have time to investigate and find out what's inside that backup, so you're not reinfecting your environment with something that could potentially re-encrypt everything all over again. This could also be part of your ransomware playbooks by integrating into your security tools like SOAR. And we can go back and use the unusual data activity alerts to find the individual backup sets that were impacted, and then get detailed data activity trends so we can actually start looking to see how far back the encryption started happening, which files were infected, which systems were impacted, and how broad the scope of attack is. This kind of gives us a time frame that may or may not align with when it actually locked up, or when security operations started to see the issue. You can quarantine from here, or you can use the quarantine bay, and that just prevents any sort of recovery with malicious content from getting back into your environment until you have the time to investigate. Another thing you can do is use federated search to search across multiple backup sets for that malicious file or other indicators of compromise. Once you have the hash value of whatever malicious code is detected, you can plug it into here and see all the backups that contain it. Anything not already quarantined but containing matching malicious code can also be added to the quarantine bay. This lets you isolate machines that may also be lurking, ready to strike next. And finally, when it comes to recovery, the last thing you want to do is either have to go through multiple backups, looking for all the correct versions of files, or accidentally recover malicious content back into place. So here you can use what's called the curated snapshot. A curated snapshot is a collated grouping of snapshots based on a time frame that consolidates all of the known good versions of the files from across multiple backups into a single restore object, allowing you to quickly recover without missing items, or worse, accidentally reinfecting your environment. With virtual machines, we can restore full VMs into isolated sandbox environments, so that once the VM is scanned and given a clean bill of health, it can be put right back into service. And with files, we scan them before we even put them back into place. The first thing you want to do is create a date range of how far back to collate the backups before scanning them, because you may have had files that were encrypted on Monday, and then some on Tuesday, and then some on Wednesday, and by Friday the entire system was shut down. You don't want to have to restore every single one of those incremental backups because you could potentially lose data or just miss some files somewhere. So by using some of the information we found in our investigation using the unusual data activity, along with our InfoSec team, we can actually determine how far back we want to collate. We would choose that here because this is creating a new backup set that we can restore from. That backup set also has its own retention policy. This can be restored in place or somewhere new depending on the situation. We can retain this recovery point for a number of days, allowing an easy way to recover known good files across a long dwell time window. Since we don't want to put anything back in place that could be malicious, we can run a scan before any data is actually restored. We can type in any known indicators of compromise or file extensions inside that backup, for example, .lucky or any of those types, and then we can actually exclude those from being restored. And then of course, the last thing you want to do when you're restoring your system from ransomware attack is re-enable all of that malicious code. So we have built-in malicious file scanner that will actually scan the backups and scan the curated snapshot before anything is able to come back into the environment. And if you had additional file hashes, like for example, something from your InfoSec team specifically about the ransomware that targeted your system, you can add it and filter that out as well. Once a curated snapshot is created, you can download the report, you can view it, and you can see which files were skipped and scanned and why. Basically, if it was malicious or it was part of the IOC list, or just something you wanted to skip using the extensions. Drilling in further, it'll actually take us to that curated snapshot. And then once you click on the curated snapshot, you can see that you can browse it just like normal and restore any and all of the files in place or into a new location. And remember, these are the collated, curated versions from across that multiple time frame, multiple backups, all in a single unified restore system. Select whichever files you want to recover and click on Restore. So that was just a brief demonstration of the Druva security capabilities within the console itself. When it comes to protecting your backup environment, alerting on unusual data activity, and restoring clean versions of files, the Druva Data Resiliency Cloud goes above and beyond just backup and restore.